All right, you guys, chapter 12, lesson 7, the law of sines. Last time we learned the law of cosines, and so we learned the relationship between the cosine of an angle and the side opposite it in relation to the other side. So you can solve any triangle using the law of cosines or the law of sines. You can't quite solve everything with the law of cosines. But you can solve anything with both of them together. So here is the law of sines without further ado. Okay, so the sine of an angle over that side opposite it creates a ratio which is maintained in any of the combinations here. So the sine of the angle A over A is equal to the sine of B over side B, which is equal to the sine of C over side C. So no matter which angle you pick, if I pick the sine of A is in ratio to its side opposite, is equal to the same ratio of any angle to its side. The sine of an angle to its side is as the sine of any other of the angles to its side. So sine A over A, sine B over B, sine C over C. You can prove this on look on page 586 of your textbook, and you can prove this using the 1/2 base times height area formula. It's pretty clever, actually. Look it up and check it out. Okay, we're going to go straight into some examples. The first example, I've got triangle ABC, where angle A is equal to 40 degrees and side A is equal to 15. Now, what would angle B be if B is equal to 20? Okay, well, we're going to use these ratios. The sine of A, the sine of angle 40, is to its opposite side as the sine of our missing angle is to the side opposite it. So here we go. We have a simple proportion and we can solve it. Cross multiply and then divide. So you have 20 times the sine of 40 divided by 15 is equal to the sine of angle B. Now the sine of angle B is going to be equal to, once you plug all this into your calculator, will be equal to 0.8571. Now you do the inverse sine and you're going to end up getting that angle B is equal to 59 degrees. Now we've got to remember, it could be this, or it could be 180 minus this. So it could also be 121 degrees. Now how do you know which is which, or both? Well, you remember that angle A was 40 degrees. So as long as 40 plus 59 is not over 180, we're fine. So that one's okay. And 121 plus 40 is 161. That's still less, so both of these answers are okay. It could be 59 or 121. Okay, let's try another one like that. It said, what would angle B be if its side was, if B was 8 this time? Okay, if B is 8. Okay, so we set up the same ratio. This is part 2 of the attempt. So sine of 40 is to 15 as the sine of this new angle is to 8. So we plug in 8 times the sine of 40 divided by 15, inverse sine, and then you're going to get that the B angle is 20 degrees, or do 180 minus 20, 160. Now, 20 plus our original 40 degrees up here is 60, so that one works out fine. Now, 160 plus 40, that's too much. 200 is greater than 180, so that's not a legitimate answer. That's our answer. Okay, let's do another example that's a little interesting. So here's a 123-foot support wire for some kind of transmitting tower. So this line is 123-foot wire holding up this little tower, and it makes a 61-degree angle. Now here's the deal. You want this to be flatter, and so we're actually going to drop this further back to make it a 46-degree angle. And now what? We want to know, whoops, my drawing got chewed up because of that. This is the 123 foot. Now what we want to know is how long is this new wire? We're not going to use the right angleness of this. We're actually going to pull this triangle out like this and just use this in the law of sines. Now, we know that this is 46 degrees. This is 123. How big is this? Can we figure it out? Yes, because these have to equal 180. So that makes this 119. 180 minus 61 is 121, excuse me. No, 119. That was right. Okay, so we're going to set this up using the law of sines. So what we can do is the sine of 46 is to the side opposite it in the same way that the sine of this other angle is to the side opposite it, the new wire. So there it is. We'll call it C. Okay, so we have cross multiply. So we're going to have sine of 119 times 123 divided by the sine of 46 is equal to the new length. And when you plug it all into your calculator, you'll get that the new length is 149.6 feet. Okay, let me know if you have any questions and you guys can get started. Thanks.